Hey students, we are starting the unit on proofs. Um, don't freak out. We will take baby steps to get there. And of course, I am here every step of the way to help you. But to start out, we need to cover this section called conditional statements. Okay, so this is going to look strange. This is math with no calculator. This is all about logic. We talked about inductive reasoning and deductive reasoning. This is using deductive reasoning when we get closer to doing proofs. Okay, so what I need you to have is the notes that I gave you today, and then your vocab folder, and then worksheet 14. Okay. All right, let's do vocab first. Now, it's a lot to write down, so if you need to pause, I'm just going to go ahead and start talking about it, but you can pause, copy, and then you can just listen. All right, so when we start writing conditional statements, we have what's called a hypothesis and a conclusion. Okay, so the hypothesis is represented by the letter P. So I'm going to highlight all of these in pink, P for pink. And the actual definition is in an if-then statement. The hypothesis is what follows if. So the hypothesis follows if. You'll see that when we get to the problems. Okay, the conclusion is represented by the letter Q, because Q kind of sounds like conclusion, Q. And I've got this represented by my yellow. And the conclusion is what follows the word then. Okay, the conclusion follows the word then. So that's our hypothesis and conclusion. We are going to use this notation. Sometimes you see it without the if, okay? So this is red. P implies Q. Q implies P, okay? So this is new wording. When you hear me say that, that's what that arrow is meaning. All right, and sometimes you see it with the if and sometimes you don't. All right, so when we have a conditional statement, I didn't look to see, oh, here it is. Okay, go back a page, page 9. Sorry, we got to get the conditional first. I knew I was missing a definition somewhere. So a conditional statement is a statement that is or may be written, that should be 2 words, a statement that is or may be written in if then form. So we're going to use P and Q. If P, then Q. This is the words, and this is the notation. P implies Q. So a conditional statement is exactly what it sounds like. It's conditional. If this is going to happen, then this is going to happen. Okay? So it's a conditional statement because of the word if. If you clean your room, then you can go to your friend's house. Going to your friend's house is conditional upon you cleaning your room. Okay, so that's what a conditional statement in geometry. It's the same thing as a conditional statement in real life. So let's put some color on this just to know that we looked at it and we have actually covered it. That's why I'm putting highlighting on these. If it's just a definition and there's not really a picture to go with it, highlight it so you know that we've covered it and you know what words you need to study. Now, it would make more sense that the hypothesis is P and the conclusion is Q. Okay, hypothesis is the part that's after the if, and the conclusion depends on the hypothesis. Okay, well, when we have a conditional statement, we have 3 other statements that we can change off of the conditional. Okay, and in geometry, we use a lot of these. Like you're going to hear me say, oh, that's the converse of that theorem. You're going to need to know that if we have converse, we have what I call the reverse. Okay, what it does is it switches the hypothesis and the conclusion. Okay, if let's see if I can think of one. If an angle is between 0 and 90 degrees, then it is acute. Okay, that's the conditional. The converse would be if an angle is acute, then its measure is between 0 and 90 degrees. And both of those made sense whichever way we wrote them. Sometimes they do make sense, sometimes they don't. Okay, so the converse is what I call the reverse. The converse is the reverse. You actually switch the P and the Q. So that means this is now your hypothesis. All right, don't get confused. This is now your hypothesis, and this is now your conclusion. Okay, but we still use the same letters. Okay, if Q, then P. All right, the inverse, and I try to make this easy for you to remember. The inverse is where you put in the not. Okay, you put in the not. So we're going to negate. Here's negation. Negation means we're just going to put in something that will change the truth value. This symbol right here is the symbol for not. Okay, so we're just going to put some color to show that we covered this. So when we put in the not, it's going to read like if not. Now remember, the inverse is off of the conditional. If P, then Q. Okay, we always go back to the conditional, go back to the conditional, go back to the conditional. So the inverse, if we're going to put in the nots, these are the two words that were added. The conditional is if P, then Q. The inverse is if not P, then not Q. If you do not clean your room, then you can not go to your friend's house. See how that works? We put in the nots. Okay. All right. So inverse, put in the not. That's the easy way to remember it. Converse is the reverse. Inverse, you put in the nots. All right. Then contrapositive is just a big old mess. It is actually the converse and the inverse together. You're doing both of those together. So I like to sometimes say it's the converse of the inverse, which means, by the way, this would be hypothesis, this would be conclusion. Okay, the converse of the inverse. So if the inverse puts in the nots, the converse means we have to switch these around. Okay, contrapositive is the converse of the inverse. Switch and negate. Okay, so notice this says if not P, then not Q. This one says if not Q, then not P. Okay, if I don't go to my friend's house, then I don't have to clean my room. Maybe. Okay, that's what the contrapositive would be. Whether it's true or not, that is to be decided. Okay, so this would be hypothesis. This would be conclusion. Okay. By the way, when you're writing the hypothesis and conclusion, notice it follows. This is an easy way to miss a question on a test. Hypothesis follows the word if, the conclusion follows the word then. It does not include those two words. So if I asked you for the hypothesis of that example that I've used, what is the hypothesis? You would say, I clean my room. If you said, if I clean my room, that's not the hypothesis. You can't use the word if. So it's the part that follows if. The conclusion is, I can go to my friend's house. Not then I can go to my friend's house. Okay, so make sure you know that. All right, let's just put some color on these two just to know that we actually talked about them. Truth value. There are so many worksheets we could do on truth value, but we're not going to do them. It has notation where you like, just in case you ever see that, and it is crazy. So we're not going to worry about doing anything with truth value right now, but we are going to talk about proofs. Okay, and then we did this one already, logically equivalent statements that have the same truth value. We covered that because it was on page 11. Okay, so go to your notes. All right, I already had this written in for you, so it's basically what I went over in the video, in the vocab. So I'm going to go over that part kind of quick. So A conditional statement, you need to find your vocab word and a definition. It's right here. A statement that can be written in if-then form. That's the definition of conditional. Okay, that's your definition. We talked about the symbolic form. I told you that this is the word implies. When you see that little arrow, P implies Q. The hypothesis is the phrase immediately following the word if, not including the word if. And the conclusion is the phrase immediately following the word then, not including then. Okay, so I gave you another set of notes right here just to show you could have a visual. A conditional statement is a statement that can be written as an if-then statement, if P then Q. Notice I've got the hypothesis in pink. I did not highlight the if. If I asked you to circle the hypothesis, you would circle it. Do not circle if. You can even cross it out. You know, this is your hypothesis. The conclusion is after the word then. The conclusion is from here to here. And so make sure you get that right because I've told you that like 3 or 4 times in these notes. Sometimes it's necessary to rewrite a conditional statement so that it's in if-then form. If I ask you to do that, you have to come up with a way to put it in if-then form and make it mean the same thing. So for example, a person who practices putting will improve her golf game. Okay, so then if I was going to write that in if-then form, if a person practices putting, then she will improve her golf game. So you can take a statement and you can write it in if-then form. 2 angles that add to 180 are supplementary. Okay, if 2 angles add to 180 degrees, then they are supplementary. See how that works? And then again, about the truth value, we're not going to worry. I might ask you to tell me if something's true. I think actually on your worksheet, I do ask you to tell me, is the statement true or false? Just to get that in your brain. But we're not going to do anything crazy with that. But a conditional statement has a false truth value. So it's false only if the hypothesis is true, but the conclusion is false. So if the hypothesis is false and the conclusion is false, then that's a different story. Okay, so we're going to practice with this, and we're going to do I do, you do, and I will ask you some questions, so be prepared to answer them when we get to them. Okay, if you live in Nashville, then you live in Tennessee. So the hypothesis is what I have in pink. The conclusion is what I have in yellow. Write that down. Okay, the next one. If the sum of the measures of 2 angles is 90 degrees, then they are complementary angles. Now, something I do allow you to do is I allow you to use abbreviations. So these are the abbreviations I allow. You can supplementary, complementary, perpendicular, angles. Make sure you put the plural, angles. And as we come across any others, sometimes like quad, okay, just to be able to fit it on there. Okay, so you can, angles you can substitute. Parallel, if you want to use, make sure you tilt it over a little bit, but you draw the parallel symbol, and so on. Okay, so if the sum of the measures of 2 angles is 90 degrees, so the hypothesis would be the sum of the measures of 2 angles. See how I abbreviated to get that to fit? They are complementary angles. They are comp angles. Okay, so you can use abbreviations for me, that is fine. All right, number 3, would you please write down the hypothesis, write down the conclusion, and it's going to be a question that I ask you. Go ahead and do that now. Okay, did you get it right? So the hypothesis is a quadrilateral is a square, and the conclusion is it has 4 right angles. I want to show you something. If I were to write the converse of this statement right here, I would say, if a quadrilateral has 4 right angles, instead of putting the it at the front, I'm going to put the it still at the back. kind of an English thing. Okay, if a quadrilateral has 4 right angles, then it is a square. That's not true, okay, because a rectangle also has 4 right angles. So sometimes you can write the converse, inverse, and contrapositive, and it won't be true, okay? All right, so writing conditional statements, this is going to give you some practice. I don't know if I'll be able to ask any questions about these because I'm limited to the number of characters I can put in the choices. So we're just going to go ahead and practice with some of these. All right, so we're going to write them in if-then statements. So the way I would write number 4 is, if an angle is obtuse, then it has a measure greater than 90 degrees. I don't agree with that definition, but that's what they had there, or that statement. It should say that it has a measure between 90 and 180, but we'll pass on. Okay, not everyone writes everything the way they're supposed to. All right, number 5. If, let's see, all numbers divisible by 4 are also divisible by 2. Okay, so that's going to be, if a number is divisible by 4, there's another abbreviation we can use. Then it is divisible by 2. Okay, see what we're doing? All right, number 6. States on the east quarter border the Atlantic Ocean. Come up with something. Maybe I can come up with a question. Okay, so the answer to my question was false. I can do true-false questions. If a state is on the East Coast, and you can have anything similar, because I know they had plural, and it's okay because I'm talking about the same thing. If a state is on the East Coast, then it borders the Atlantic Ocean, okay? So that is the best way to write that. Okay, number 7, Valentine's Day is in February. So this is how you could write that. If it is Valentine's Day, then it is February. Okay, that may not be the only way you wrote that. You could have said, if today is Valentine's Day, then it is February. If a day falls on Valentine's Day, then that day falls in February. That's a little, redundant, but this is actually the best way to write that answer. Okay. Number 8, try it by yourself. All right, so number 8, I have, if a number is prime, then it has 2 factors, comma, 1 in itself. Another way you could write that, if a number is prime, then its only 2 factors are 1 in itself. If you didn't want to put that pause in there. All right, turn your paper over. All right, here's where we talked about the inverse, the converse, and the contrapositive. I don't like this order. I always go converse, then inverse, and then contrapositive. Okay, so the converse is the first one that we looked at, and that's formed by switching the hypothesis and conclusion, and the symbolic form is Q implies P. Then we had the inverse, and that was formed by negating, putting in the negative, putting in the not, negating the hypothesis and conclusion. That's off of the conditional. So remember, that is not P implies not Q. Okay, then the contrapositive is formed by negating. I love doing this because I teach you in the vocab and then I'm teaching you again, so you're getting enough instruction on this. Negating and switching the hypothesis and conclusion. So that is not Q implies not P. So remember, it's the converse of the inverse. I like that. It's the converse. It's the converse of the inverse. You take this and you switch it around. Which, when you're doing your steps here, it'll be easier to see what we're doing because we will do the converse, we'll switch it around, then we'll do the inverse and put it in the knots, and then you switch that answer around to get that. Okay, so what we're going to do is we're going to write the converse, the inverse, and the contrapositive of the conditional statement. You can use abbreviations if they're there. We're going to do 2 examples. Okay, so if it is Saturday, then there is no school. I'm just going to put true, false also. So that is true. Okay, now we're going to write the converse. The converse switches the P and the Q. So we're going to say, if there is no school, then it is Saturday. So do you think that's true? No. It could be Sunday. It could be a holiday. It could be the summer. Okay. So I'm going to put false out here just because I want you to see the truth value in these because that may play an important part later on. Okay. Now we're going to write the inverse. We go back to the original and we put in the knots. If it is not Saturday, you can abbreviate Saturday. Then there, now, how are we going to say this? You know, we don't say, then there is not no school. Okay? That is not English. That is bad, bad language. So then there is not no school would mean there is school. So watch your double negatives. Okay? Watch your double negatives. So if it's not Saturday, then there is school. Is that true or false? No, once again, it could be the summer, it could be Sunday, it could be a holiday, so that is false as well. Okay, now we're going to put the contrapositive, which means we're just going to switch this around. Okay, if there is not school, okay, or if there is school, sorry, if there is school, so we're putting in the negative here and the negative here, we're switching it around. Okay, so if there is school, so that was negating, and we've switched, then it is not Saturday. Okay. If there is school, then it's not Saturday. Okay. So I would say for the most part that's true. If we're in school, it's not Saturday. When's the last time you went to school on a Saturday? Okay. So I'm going to say that is true. All right. I want you to try number 2. Okay. I want you to try number 2. You're going to write it all out. I might, ask you a question, but I don't know if I will. So I'm going to stop the video and I want you to do number 2. I probably will ask you some kind of question. Go for it. Okay, look at what I've got. Look at the true false. True for that because that is true. By the way, 32 degrees is freezing. If you didn't know that magic number. So if the temperature is 25 degrees, then it is below freezing. The converse, if it is below freezing, and you can say if the temperature is below freezing, which is probably what I should have done. In English, like your your pronouns are usually referring back to a noun. So that, and I minored in English, okay? That's why I know that. So you can have these 2 words switched. In fact, if you did that, pat yourself on the back. You are superb. Okay, so it should kind of be if the temperature is below freezing, then it is 25 degrees, or the temperature is 25 degrees. But I'm okay with exactly what's written here. Okay, I'm not that picky, by the way. All right, so if it's below freezing, then the temperature is 25 degrees. That is false because what if the temperature is 24 degrees? That is still below freezing. All right, if the temperature, this is A was the converse. By the way, if you miss the question, then you got to pay attention to the words. I said this is the correct inverse, and that is not the inverse. Pay attention, okay? All right, this is the inverse. If the temperature is not 25 degrees, then it is not below freezing. Well, that is false as well, because if it's not 25 degrees, it could be 2 degrees, and it's still below freezing, okay? And then the contrapositive, remember we take this statement here, the inverse, and we reverse it. So that's the easiest thing to do, is to write this one just in backwards form. If it is not below freezing, then the temperature is not 25 degrees. That is true, because if it's not below freezing, it has to be above 32, and the temperature would not be 25 degrees. Okay. All right. So we're getting ready to go into proofs. So I thought I would do a little review on the algebra proofs. You do need to go back and look at the notes on the algebra proofs and get those words in your head. We're going to see them again in the next couple of days, but it would be a good idea to go ahead and get them in your head. So I'm going to do this one with you, and then I'm going to ask you a question about this one. Okay, maybe a couple of questions. I may even ask you every question. And if you guys get these right, then that's a lot of points that you're going to get for those answers. Okay, so remember, when we're doing proofs, the first answer is given, because that's what's given up here. What we're trying to prove is down here, but you never write prove right here. Okay, and you look at the first step and say, what did they do to get from here to here? And then you write your answer over here. Okay, so 6x plus 7 equals 8x minus 17. It looks like we have the 7 and the 6 is gone, so they subtracted 6x from the left and the right. So that is the subtraction property of equality. From here to here, it looks like they added 17 to the left and right. That is the addition property of equality. Then we divided by 2. So that is the division property of equality. And it's backwards. In math, we like to have the x on the left and the numbers on the right. So we switch these around, and that is the symmetric property. Okay, it doesn't really have to be a property of equality. I can't remember if it was listed as POE, but that's fine. Okay, because now you do need to try to write this, but if you left it off, I would not count wrong. But if you start leaving it off of everything, we will have issues. Okay, all right. So if you need to go back and look at your notes as you're doing this, that might be a good idea. So I'm going to pause the video. You're going to fill in all the answers, and I'm going to probably ask you a bunch of questions. Okay, here's your answers. As you went through, hopefully you got those right. Okay, that's the end of the notes, and we will do worksheet number 14 in class the next time I see you. Thanks, students. Keep up the hard work.